Natural language processing, NLP, is a field of artificial intelligence that focuses on the interaction between computers and humans through natural language. The goal is to enable computers to understand, interpret, and generate human language in a way that is both meaningful and useful. NLP combines computational linguistics with machine learning and deep learning models to process and analyze large amounts of natural language data. This presentation will delve into the steps involved in training, evaluating, deploying, and testing a language understanding model, providing a comprehensive guide to implementing NLP solutions. Language models are the backbone of NLP applications. They are designed to understand and generate human language by learning from vast amounts of text data. These models can perform a variety of tasks such as translation, sentiment analysis, and question answering. The most common types of language models include rule-based models, statistical models, and neural network-based models. In recent years, transformer-based models like BERT and GPT have revolutionized the field by achieving state-of-the-art performance on many NLP tasks. The first step in training a language understanding model is data collection and pre-processing. This involves gathering a large corpus of text data relevant to the task at hand. The data must then be cleaned and pre-processed to remove noise and inconsistencies. Common pre-processing steps include tokenization, stemming, lemmatization, and removing stop words. The quality of the data and pre-processing steps significantly impact the performance of the model, making this a crucial phase in the NLP pipeline. Training a language understanding model involves feeding the pre-processed data into a machine learning algorithm. This process requires selecting an appropriate model architecture, such as a recurrent neural network, RNN, or a transformer model, and configuring hyperparameters like learning rate and batch size. The model learns to recognize patterns and relationships in the data through multiple iterations, adjusting its parameters to minimize error. Training can be computationally intensive and may require specialized hardware like GPUs or TPUs. Once the model is trained, it is essential to evaluate its performance to ensure it meets the desired criteria. This involves using a separate validation dataset to test the model's accuracy, precision, recall, and F1 score. Evaluation metrics provide insights into how well the model generalizes to new, unseen data. Techniques like cross-validation and confusion matrices can help identify areas where the model may be underperforming. Continuous evaluation is crucial for maintaining the model's effectiveness over time. Hyperparameter tuning is the process of optimizing the parameters that govern the training process of the model. These include learning rate, batch size, number of epochs, and more. Proper tuning can significantly enhance the model's performance. Techniques such as grid search, random search, and Bayesian optimization are commonly used for hyperparameter tuning. This step often involves a trade-off between computational cost and model accuracy, requiring careful consideration and experimentation. Deploying a language understanding model involves integrating it into a production environment where it can be accessed by end users. This requires setting up an API or a web service that allows applications to interact with the model. Deployment also involves considerations for scalability, latency, and security. Tools like Docker and Kubernetes can help manage the deployment process, ensuring that the model runs efficiently and reliably in a production setting. Continuous monitoring is essential to maintain performance and address any issues that arise. After deployment, it is crucial to test the model in a real-world environment to ensure it performs as expected. This involves monitoring the model's predictions and comparing them against actual outcomes. A/B testing can be used to compare the deployed model with previous versions or alternative models. User feedback and error analysis are invaluable for identifying areas of improvement. Regular testing helps maintain the model's accuracy and reliability, ensuring it continues to meet user needs. Model drift occurs when the performance of a language understanding model degrades over time due to changes in the underlying data distribution. This can happen due to evolving language use, new slang, or changes in user behavior. To handle model drift, it is essential to continuously monitor the model's performance and retrain it with updated data. Techniques like online learning and incremental training can help keep the model up to date. Regularly scheduled evaluations and updates are crucial for maintaining the model's effectiveness. Implementing NLP solutions comes with ethical considerations that must be addressed. These include issues related to data privacy, bias, and fairness. It is essential to ensure that the data used for training is representative and free from biases that could lead to unfair or discriminatory outcomes. Transparency in how the model makes decisions and the ability to explain its predictions are also important. Adhering to ethical guidelines and regulations helps build trust and ensures the responsible use of NLP technologies. The field of NLP is rapidly evolving, with new advancements and trends emerging regularly. Future trends include the development of more sophisticated models that can understand context better, such as those based on transformers and attention mechanisms. There is also a growing focus on multilingual models that can understand and generate text in multiple languages. Additionally, advancements in hardware and computational resources are enabling more complex and powerful models. Keeping abreast of these trends is essential for staying competitive in the field of NLP. Implementing a language understanding model involves multiple steps, from data collection and preprocessing to training, evaluating, deploying, and testing the model. Each step is crucial for ensuring the model's accuracy, reliability, and effectiveness. By following best practices and staying informed about the latest advancements, practitioners can develop robust NLP solutions that meet user needs. The next steps involve applying these principles to real-world projects, continuously learning and adapting to new challenges and opportunities in the field of NLP.